So talking about the algebra again, just to kind of reinforce the importance of this is that my experience with students and myself included when I took math classes at the college level, I was anxious to get my homework done, and so I didn't really appreciate the benefits of the actual time that I spent doing the problem. I mean, all you're going to turn in is your homework, and you just want to make sure that you're getting the answers right. But that time that you're spending doing that homework, that is a quantifiable component of your learning, and nothing can substitute for that time. So that's why I say make sure when you're doing this math that you're taking your time and spending the time to actually practice and develop those algebraic skills. For number 13, what we have here is we have a ball that's being thrown up in the air, and they're giving us the equation of the position of this ball as a function of time. And what we would like to know is how fast, or what's the velocity of the ball at t equals 2 seconds. Well, we know that, when we're looking at a function, of a position function, when we take the slope, the rate of change, what we're finding is the velocity. Okay, so that's what we're going to do here. And for this particular problem, I'm going to take the approach of letting h approach 0. So let's start off. We'll let s equal 40t minus 16t squared. S is kind of standard notation for position. That's our position function. And I want to let the limit of as h approaches 0 be s at 2 plus h minus s at 2 over h. And I'm going to go ahead and calculate what s at 2 is. So if I do all of my math and plug 2 into my function, I find that it's 16. All right, so the limit as h is approaching 0 is, substituting 2 plus h into my function, I get the following for my numerator and h for my denominator. And again, I just keep going, and as h approaches 0, multiply everything out, distribute, and I get all of this over h. Now remember, we're stuck with the same problem. I don't want h to equal 0, because if you look in the denominator, it'll be undefined. We're only interested in h approaching 0, so I need to somehow simplify out that h down in the denominator. So, you know what, I think on the previous stuff I was putting a t down there. It's supposed to be h. The limit as h approaches 0. Go ahead and combine our like terms. We're going to end up with the limit as h approaches 0 of negative 24h minus 16h squared over h. And if we simplify out an h, we're going to get the limit is equal to negative 24.